Graph the following inequalities on the given number lines. This says x is greater than negative 3. So first I'm going to draw a circle at negative 3. I need to decide whether it's an open circle or a closed circle, and I decide that it's open because it's closed when there's a line underneath, right? So like this is closed, right? But this is open. And it's a line underneath that makes a difference, right? So this is also closed and this is also open. So closed circle, open circle for this symbol, and then it says x is greater than negative 3. So for negatives, like negatives can be a little bit tricky. I think, is 0 greater than negative 3? Yes, yes it is, right? 0 is greater than negative numbers, and so I'm going to shade this direction towards 0. Okay, these are all the numbers greater than negative 3. 1, 2, those are greater than negative 3, right? Even if you're a little confused about the negatives, we know that these numbers are definitely greater than negative 3. Next one. X is less than or equal to 1. And remember the way that I remember the signs, right? This is greater than the less than sign. Here's my hand, looks like an L. That's the less than sign. This is the less than sign, right? And then the other way is the greater than. This X is less than or equal to 1. So draw a circle at 1. Decide if it's open or closed. In this case, it's closed. And that says less than. What's less than 1? 0 or 2? Well, 0 is less than 1. I'm going to shade that direction. Right, shade towards the numbers that make it true. Write the following statements using mathematical symbols. A number, we don't know the number, let's call it x, is greater than negative 5. Okay, just like that. 12 is less than or equal to a number that's x. Solve the following inequalities and graph them on the given number line. Okay, so let's take a look. I have an equation. Now I need x by itself. So right now, the only thing, so I'm going to draw a line. A lot of you really benefit from this strategy where you draw a line on the equal sign, or in this case, the inequality sign. So what's with the x right now? I want to get x by itself. The only thing that's with the x is the minus 7. So the only thing I have to undo is plus 7. This cancels, leaving me with x. And then I'm going to do this the long way, just, right? This is 12 negatives and 7 positives. 1, 2. So, I've done this a little bit neater, would have made my life easier. But what's left is 1, 2, 3, 4, 5 negatives. Okay. So I have negative 5 is greater than x. And remember, I really prefer to have the variable on the left side. So I'm going to rewrite it. I'm going to switch the x and the negative 5. And then, of course, that leads me to switch this sign as well. So it's x is less than negative 5. And I'm gonna rewrite it just right below this line where we can sort of see it without that line down the middle. X is less than negative 5. So let's put negative 5 in the middle here. And then what would be on either side of negative 5? Well, remember with negatives it sort of goes in reverse, right? This would be negative 4, negative 3. And you can cheat a little bit and look at the number line at the front of the room to help you. And draw a circle at negative 5. Is it open or closed? Open. It says x is less than negative 5. Which way are the numbers less than negative 5? Well, let's think. So 0 is like this way, right? So 0 is greater than negative 5, right? Like 10 is that way. 10 is greater than negative 5. But we want less than, so we're going to go this way. Here we go. I see parentheses. Let's distribute. Negative 4 times 3 is negative 12. And negative 4 times n is negative 4n. Less than or equal to negative 32. Okay, here's my inequality sign. And now I'm going to start moving things from one side to the other, right? Here's my variable. I want to get that by itself. So I have negative 4 being multiplied by it, and then negative 12 being added to it. So remember, I deal with addition and subtraction first, so I'm going to take care of the 12 first. Negative 4n, bring down less than or equal to. Negative 32 plus 12. This is negative 20, right? And imagine I have 32 negative signs listed and then 12 positive signs. Well, 12 will cancel, but there'll be 20 negative signs left over. Okay. Now, I have n times negative 4. So I'm going to divide by negative 4. Divide by negative 4. And here's where you have to remember, right? And this is just important that you just remember. There's no secret to it. You just have to think about it and remember it. The sign flips. I divided by a negative number, right? This line of work right here, where I divided by a negative number, it makes the sign flip. So this goes from a less than or equal to a greater than or equal to. Negative divided by negative is a positive. 20 divided by 4 is 5. N is greater than or equal to 5. Here's 5, 6, 7. I'm going to draw a circle at 5. I decide if it's open or closed. It's closed because it's or equal to, right? That's what makes it a closed circle. And this says n is greater than or equal to 5. So that tells me to go to the numbers that are greater than 5, which are like 6 and 7. Number 5. 9 is greater than negative 2m plus 3 minus 4. So the first thing I notice is on the right side, I have like terms. Positive 3 and negative 4 are like terms, so I'm going to bring down everything else. And I'm going to combine positive 3 and negative 4. So these cancel. I'm left with negative 1. Then m is the variable. I'm trying to get it by itself. So the first thing I'm going to do is I'm going to add 1 to both sides. Then I'm dividing by a negative 2. Dividing by a negative 2. And right away you should be thinking to yourself, wait a second, what happens when I multiply or divide by a negative? The sign flips. Okay, you just have to remember there's no secret to it. So here's the m. 10 divided by negative 2 is negative 5. And the sign flips around. But then I want the variable on the left side, so I'm going to actually end up flipping it back around. Right, this is this way, and now I'm going to go the other way. That flips around. M is greater than or equal to negative 5. Negative numbers kind of end up going in reverse order. Open circle negative 5, and then I decide is it closed or open? Well, this symbol has a or equal to underneath, okay? So that makes it a closed circle. And then it's greater than negative 5. So I think which direction are the numbers that are greater than negative 5? Well, that direction is like 100, 500, a million, right? Those are all numbers that are definitely greater than negative 5. In this direction are more negative numbers, but those get smaller and smaller, not bigger and bigger. So I'm going to shade this way. Okay. And number 6, last problem. Determine the smallest integer that makes this equation true. Show work. Okay. So I'm going to just recopy the equation a little bit bigger so it's a little bit easier for us to see. Now if you just started solving right there, that's fine. That's totally fine. But just make it easier for you to see here. First thing I notice is like terms. So that's negative 3 and negative 5. Nothing cancels here. There's no plus signs. It's just a total of 8 negative signs. This is x times negative 8, so that's being multiplied. And this is plus 7. We do get rid of addition and subtraction first. 15 minus 7 is 8. Then I'm dividing by a negative. Remember, when I divide by a negative, the sign flips. 8 divided by negative 8 is negative 1. Okay, now let's imagine for a second a number line. I'm going to draw it so we can talk about it a little bit. Here's negative 1. X has to be greater than negative 1, right? That's what my equation determined. So it can't be negative 1, right? It's not allowed to be negative 1. It can only be greater than negative 1. The question is, what's the smallest integer that makes that true? Well, let's think. If x is greater than negative 1, some possibilities, it could be 0, it could be 1, it could be 10, it could be 100, right? It could be 42. Those are all possible values that x could be if the only requirement is has to be greater than negative 1. So the question is, what's the smallest integer? So it can't be a decimal, right? And what's the smallest number it can be? Well, let's look. If I start at -1 and I go bigger, the first integer I hit is 0. So the answer would be 0. The smallest integer that this can be is 0.